Assalamualaikum. My name is Ali Fazhan bin Abdul Rahman. We from Group 1. So this is my group members, Ahmad Haris Daniel, Muhammad Amir Aiman, and Muhammad Arif Aiman, and Ahmad Qayyum. So for the introduction, process control system, also known as industrial control system, position along the manufacturing production line. So mostly the process control system is used in manufacture like Samsung and Epson and other manufacturer. And you also perform a test and provide data for monitoring and troubleshooting. Next is a PID controller. It's short for proportional integral derivative controller, and crucial in industrial control system and continuous modulated control application, and comprises three components: proportional, integral, and derivative. And next, robust PID utilize a back calculation method. It involves recomputing the value of integral gain when the controller output saturates, so that new value of integral gain will produce and lead the controller output to be within saturation limit. Okay, next. So this requirement for this this assignment. So for the set point is 150 Celsius, and overshoot is less than 6%, and settling time is less than 1650 seconds. And steady state error for last 2500 data processes is less than 1.5 times 10 Poser native part. And duration of system operation for each batch is 5000 seconds, and initial temperature at 27 Celsius. Next. So this is a methodology, the process of our assignment flow. So we start and analyze the coconut oil heating process, open loop response using a 5-volt input signal, and then we construct the first order FOPDT model, and we create an open loop system based on the FOPDT model using Simulink. So next, match the open loop response. If no, you go back to the construct the FOPDT model. If yes, you proceed to calculate the parameter of the PID controller using the chosen tuning method. And next, create a closed loop system with designated PID controller. And next, for fulfill the specification, if yes, it will end the project. If no, it will apply the back calculation anti-wind-up scheme in the robust PID design. And then if fulfill the specification, if no, you will go back to apply the back calculation. If yes, the assignment is done. Okay, I will pass to my friend.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Aiman bin Muhammad Yusuf, and I will do demonstration regarding the open loop calculation. First of all, at the figure 1 is the open loop response that we obtained from the assignment. Okay, first of all, we need to find the scale for the x-axis and y-axis. Okay, the scale obtained for 500 seconds is equal to 2 centimeter. Then for 1 centimeter is equal to 250 seconds. For y-axis, for 50 degree is equal to 1.7. Then 1 centimeter is equal to 29.41 Celsius. Then we can obtain the time delay. We construct this using the FOPDT model. Then we obtain the time delay for this open loop response is equal to 150 seconds. Next. Then to find the gap magnitude, which is A value, we need to find the maximum value of output response and minimum value of output response. From the loop response, we obtain the value for maximum value output response is equal to 232.35 Celsius, and the minimum value is equal to 26.47 degrees Celsius. Then we can obtain the value of gap magnitude, which is equal to 205.88 degrees Celsius. Then for the B value we obtain is equal to 5 volt. Then from there we can get the gain for the process, which is the formula is A over B, and we obtain the K value for this open loop response is equal to 41.18. Then we need to obtain the 63.2% of output response, and the value that we obtain is equal to 156.59 degrees Celsius. Next, we need to obtain the time period for 63.2%, and from the graph we obtain the value for the time period for 63.2% is equal to 1100 seconds. Then from there we can obtain the time constant, which is equal to tau. From the calculation, we obtain the value for tau is equal to 950 seconds. Then from there, we need to insert into the equation. Then we obtain the FOPDT equation as the figure show. Next. Here is the block diagram for open loop system, and we can do the demonstration. Okay, here is the block diagram for the open loop. Then we can run to obtain the results. Okay, from the block diagram, here is the response that we obtain, which is the settling time for this open loop is equal to 2657 seconds, which is not which is excess from the requirement. Okay, so we need to do the PID controller to get the requirement from the pisang tanduk. Okay, next I will pass to my friends Muhammad Amirul Aiman.
Hi and Assalamualaikum. My name Muhammad Amirul Aiman Birofli. So for PID parameter calculation, our group use Ziegler-Nickel tuning method formula. So first we must calculate the professional gain KP. So we get 0.1846, and then we find the TI integral gain, integral time. So we get 300S, and then we find the integral gain KI. We get 0.006153 per S, and then for the derivative time TD. So we get 65S, and then for the last we must calculate the KD derivative gain. So we get 13.45445S. Next. Okay, this block diagram of PID. For the heating process, we must input the equation from open loop, and then it has three gain KP, KI, and KD. So from again, we must include from the open loop calculation, we put the value into the KP, KI, and KD. Next. So for PID demonstration and analysis, so this is our PID at MATLAB. So we run. Then we go to the scope, so we can know that is have a rising time is an overshoot. So the settling time and the static error is requirement from the assignment is finished. Then we go to coding to get the output response. So from the output response, for the settling time is 33,231. So this finish, and then we go to the overshoot is less than 46. So we get 40.7039. So it's finish, and then for the static error we get negative 0.0017. So this requirement is finished. Next, I will pass to my friend.
Assalamualaikum and greetings. My name is Samad Koyum bin Ahmad Johan. So I'm going to present regarding our robust PID calculation. Okay, so this is the formula for the tracking time constant, which is TA equal to square root of TI and TD, where the value of TI is 300 and value of TD is 75, so we get 150. And here you can see the value of 1 over TA, where we get the value is 0.006667. Okay, so this is the block diagram that we construct in Simulink. Okay, as you can see, we input the value of 1 over TA at the lower side, which is you can see the value of the TA 0.006667. Okay, and then we can start running the simulation. Okay, so this is the graph, which is the system response. Okay, and as you can see, based on the pattern of the graph, it have achieved stability where you can see there's no, I mean, it aligns with the set point. Okay, now, okay, we're gonna find the value of the settling time. Okay, so you can see here, the value of the steady settling time that we gain is 1.4312, and then the value of the overshoot, which is 4.3728, and also the value of the steady state error, which is 6.9934, is much more stable compared to the previous PID controller, and the settling time is also much faster. Okay, so for the comparison table, we're going to make a comparison for the PID controller and the PID controller with back calculation anti-wind up scheme. Okay, on the left side is the parameter, which is the specification, the overshoot, the settling time, and also the steady state error. Okay, the first column is the parameter that has been set by the Pisan Tanduk Holding, where they required the overshoot value supposed to be less than 6%, the settling time less than 1650, and the MSE and the steady state error, which is MSE less than 1.5 times 10 to the power negative 4. Okay, so the second column is the value that we get for our PID controller, where after running the simulation, we get the value of the overshoot about 40.7039%, while settling time we get 3231, and the steady state error value we get negative 0.0017. And then the third column, the PID controller that we have designed just now has been included with the back calculation anti-wind up scheme, where after running the simulation, the value that we get for the overshoot is about 4.3728, while the settling time is about 1431, and the steady state error value that we get is 6.9934 times 10 to the power negative 6. Okay, so based on the value of the third column, uh, we able to follow the specification that has been set by the Pisang Tanduk Holding. So that's all from our group. Thank you.